So we're going to take a little look at Revit MEP today and just have a quick overview for the next half an hour, 45 minutes or so on the tools that are available inside of Revit MEP and potentially how straightforward they can be to use. And certainly if you're currently working in AutoCAD, these tools inside of Revit can certainly make your life a lot easier. So I've opened up this file and the first thing we can see is, because it's Revit, yes, we have a 3D architectural building in there. What I just want to point out very quickly, so if I just scroll down here in my browser, we can just see that we've got a Revit link configured. And I just wanted to point out that the building that you can see in front of you, okay, that is linked to another Revit file. Why is this important? Essentially, we're collaborating here. We've potentially received this file from an architect. We're creating our own Revit file with all of our MEP information, all of our HVAC, lighting and plumbing. And we're putting that into a separate file, but linking that to the architect's model. So inside this model, I don't actually have any walls, windows, doors, floors or ceilings, etc. that I have built. Before we go any further, I just want to quickly and briefly just discuss some important elements of the user interface that you'll see me using over the next 45 minutes or so. First things first, we have the ribbon bar along the top. No matter what Autodesk software that you're using, you will be used to a ribbon bar by now inside of AutoCAD or Revit Architecture or any other Autodesk software. And this ribbon bar is basically split into several different tabs, and each different tab has several different panels. The panels are where you find the tools that you're going to be using, okay? And it's split up really intuitively. So if you want to add a HVAC system, you would go to the Systems tab, go to the HVAC panel, and you can see all of the information and all of the tools required for you to place that HVAC system into your building. The same for plumbing and piping. If you go to Systems, you have a plumbing and piping panel which contains all of the necessary tools to add your plumbing and piping into your building. In the center of the screen is obviously where we have our model, our 3D model, and when we do the majority of drawing, you'll be glad to hear that inside of Revit MEP we actually do all of our design work in 2D and kind of get the 3D for us automatically, which is great. On the left hand side we have two sections of the user interface. We have our properties. With Revit and with BIM, metadata is all important. So when you select a product or an item or a component, it's going to give you a full breakdown of that component and allow you to view, edit and change metadata as necessary. At the bottom left of our screen we have our project browser. Our project browser is essentially splitting our file up into several sections. Okay, you can see that I have a number of floor plans, from lighting floor plans to HVAC floor plans, ceiling plans, 3D views. Generally inside of Revit we have a single 3D model, but that model is broken up into several different views. Those views could be 2D, 3D, schedules, legends, reports, so on and so forth. It's relatively easy to set these up. We're not going to go through that today, but it's just a case of you set up a level inside of Revit, and then those levels are linked to one or several views. Might be duplicated views to show different information. So moving back to the fact that we have a 3D model, fantastic use for an architect, but not always that useful from an MEP engineer, you might be thinking. However, with this 3D building, it's very quick and easy to manipulate. We could quite quickly crop this down and start looking at some very quick 3D sections. So let's just move some of these cropping grips to have a look inside this building. We can then use our 3D navigation tools to orbit, rotate, pan and zoom in and zoom out to see inside the ceiling voids, have a look at our configuration of vents and ducting, and even come in and select components in 3D space and physically be able to see inside our properties what that item is, what that 3D representation should be in the real world. This is where 3D comes into its own and becomes very, very powerful. I'm just going to zoom back out. Not quite that far. Let's just zoom back in. And the first thing we're going to do with this file is we're going to go into a mechanical floor plan and just have a look at our HVAC configuration. So if we come down in our project browser on the left hand side, we've got HVAC floor plans and I have a mechanical level. If I give that a double click, that will just open up my mechanical floor plan. Okay. Now as you can see, I've already got a number of VAV units in here, a number of terminals and a number of ducts that are already pre-configured. Just to save ourselves a little bit of time throughout this demonstration, I've also got a number of terminals here, okay, and a VAV unit that I can use to connect them together. And that's what we're going to be doing in just a second. Before we do that, just very quickly, we have got the architect's model in here, and I've just configured what I can and can't see. So for example, here there was a ceiling grid, and that ceiling grid has been used to correctly line up these terminals so that they are all in line, not just with each other, but with the ceiling grid as well. I've simply then just turned the ceiling grid off, made it invisible, so we've got a nice clean view in front of us. If you wanted to place in either a terminal or a mechanical component, such as your VAV unit, it's very straightforward to do so. We have a specific button for mechanical equipment, which we can press, choose from a loaded family type that we have, and simply click to place this down into our floor plan. Because we are looking at the level 1 mechanical floor plan, that item would be aligned with inside that level in Revit. More on that a little bit later on. The same with air terminals. If you wanted to add an air terminal, you would go up to the air terminal tool, choose one from your loaded families, choose how you would like to place it, and then drag and drop it and click inside your file. As I said, we've already got some added just to save ourselves a little bit of time. But before we go and add in any ducts, I just want to pan over just to this section up here. I've got a little office here which has got a terminal being driven by this VAV unit here, and that's got a specific airflow through there. Now inside of Revit we can extract any amount of data that we might want to extract. Okay? We can schedule anything inside of Revit out onto a schedule list. For instance, inside this office I have a single terminal which is linked to this VAV. Obviously there's a certain airflow through here that's going to be looking into this room and looking at the airflow within this room. I'm just going to come down and have a very quick look at the schedule. So I've got an air terminal schedule. If I just give that a double click to open that up, I can just press WT with inside Revit, okay, just to tile the windows. And then we can see that we've got our schedule on the right hand side and our model on the left hand side, both of which I can use and amend should I need to. So if we look over here on the left, I'm just very quickly going to go up to my annotate tools and say that I would like to tag this terminal. It gives me an ID 37 and shows me the flow through that terminal. I can match that up with what I have over here on the left hand side. We can see that in Office or Space 101, more on the spaces in a second, we have Terminal 37, which has a specific flow. Now inside of this schedule, I've simply done a simple calculation here to say that we've got a calculated figure based on the space and an actual supply airflow based on what's coming through our terminal. We can see that that's just been set to 165. This has given me a difference between these two values of 82. So I've just set up a little bit of conditional formatting in here just to say if you go over that figure or that difference is more than, let's say, 10%, 20%, whatever you need it to be, it will highlight it for you, okay, to say that it's potentially too high. All I want to do very quickly is show you that we do have a live link. So if I come across here inside of my schedule, okay, I can come into the flow for this terminal and change it. For example, I could drop that down to 75. If I press enter, not only does my schedule update, but you'll also notice on the left hand side of my screen it's physically updated my 3D model. So my 2D floor plan and my 3D model is now up to date with those changes that I have made directly inside my schedule. And that works both ways. If I come back into the model, select my terminal, I could come into, let's just make sure that we're not adding more tags there. I can come into my properties, okay, select the terminal. This gives me all of the information. If I come back up to the mechanical flow and drop that to 72.5 and press enter, before I press apply, again that will update the model and it will also update my schedule. That's all important with Inside Revit. It means that you have a single source of information. Even though that source of information can be edited in several areas, you're always linked together. Let's just temporarily close that schedule. We'll come back to that a little bit later. And let's just open up our floor plan once more. What I want to do before I go any further is just discuss the spaces a little bit. As we've just been looking at those through the schedule, I'm just going to come back to my HVAC, back to my floor plans, and you notice that I've got, again, some pre-configured views for spaces and zones. Now when the architect puts the Revit building together, they're going to be defining rooms as rooms inside of Revit. So they'll be putting room tags on there and information about the size of those rooms, the area and the volume, etc., etc. What the rooms are used for example. When we're looking at it from an MEP point of view, that information can be useful for us, but we're more interested on the use of the room, the size of the room, and then looking at potentially the flow of the room and what flow we need to keep that room at a specific temperature or with a certain amount of fresh air. So we can come down and we can see that we've got spaces configured. Okay, they're very easy to configure. We have necessary spaces and zones tool to come across and set these zones and spaces up. So you can see I've got this office over here that we were looking at earlier. I can select that office, and again we get in our properties, roll out a number of HVAC and MEP specific properties. As well as having spaces, we also have the ability to configure zones. Zones are essentially a number of spaces linked together. You can see in this instance we've had them put together with a colour map, more on those later, to see exactly what we have in our building. For example, these three rooms here could be run by the same ducting system. So we can select all of those as a single entity, a single zone, and we can have a look through again and grab all of that analysis and HVAC information from our properties. What I want to do before I go any further is just calculate some analysis on the heating and cooling for this building. And this is basically going to be looking at the spaces and the zones that we have configured. So let's come up to Analyze on the ribbon. Let's go across to Reports and Schedules, and we have Heating and Cooling Loads. So inside of this dialog box, we first and foremost, on the left hand side, we've got a small preview of our building. It is in 3D, so you can come in here and orbit around just like we can inside of the main Revit model, and we can zoom in and out and pan around just as normal. What I can do is have a look at some specific properties and set some parameters on the right hand side to decipher, okay, well, what is this building? What's its predominant use? At the moment we have that configured to be an office. Okay. You can see that we've got a load of pre-configured options in here which will look at the type of building that you have selected and give you predetermined calculations to go through and figure out what kind of airflow you would need inside that building. Generally speaking, inside of a building you've actually got several different types of room, or in our case here, spaces. So we've got an office here, But actually within that office we might have a food preparation area, somewhere where colleagues and employees can go and eat. We might have a training room full of people and electrical equipment, and each one of those rooms is therefore going to have a different airflow and a different MEP calculation needed to get the correct fresh air intake and airflow into that space. So we're going to come to how we do that in a second, but we're just going to say that generally the building as a whole is an office. It's based at a specific location. Now we can open this up and use an internet mapping service. It does use Bing Maps, but literally you can come across and change the location to anywhere on this map. You can literally just pick up and drag this location, type in a specific coordinate, okay, or a specific address. This is essentially going to pick up some historical weather information from that location. It will pick up average temperatures over the course of a year, and those will be used as an average minimum and an average maximum to calculate our heating and cooling requirements. Just going to cancel that away and leave it on London, UK. We've got a number of other options here which I'm just going to leave as default. We could go across to details. If we look at details, it's breaking our building model down into all of our different areas and zones. Okay. We can select a specific zone or area, space, sorry, and even go as far as to say that we would like to isolate that on the model to see where it is. It might be that eventually we want to see if this window is having any effect on the airflow within that room. Is the window adequate enough based on the way that the wall's facing and the outside elements? Is that causing there to be a bit of a problem with the airflow within that room? We can pick up on any of these spaces and change the type, again from this list of default settings, and that will give it some different parameters for the calculations to run. Again, we're going to leave this all as default just to make our life a little bit easier. Once we're done, we can simply press calculate. Now, depending on the size of your Revit model, this might take a few seconds or a few minutes. But this is now going to calculate our building, look at all of our zones and all of our spaces, and calculate our heating and cooling loads per space and per zone. Once that's completed, you'll get given a report. This report will be saved inside of Revit under the reports section as a load report. That means it's accessible at a later date very quickly. And this report, as you can see from the scroll bar on the right hand side, is pretty detailed. It's containing all the information about the project, the building, some zone information. Okay. You get this for each zone that you've configured, and in each zone, as well as getting general areas, volumes, cooling set points, etc., you also get to take a look at your components. Now, depending on how the architectural model has been drawn and how you've configured your report type, in this instance we can only see walls as a single entity. Okay, we can see the cooling loads, the loss. Okay, you can set this up in a specific way to view all of your walls separately. Therefore, if you've got a wall that's problematic, perhaps it needs to be a different type of wall, a bit more insulation, or whatever it may be, we can split that out to look at if there's a specific wall or window or door that is causing dramatic loss inside that area. We also have the ability to come in here and say, okay, we've got some hyperlinks. Let's click on this one, 111 Office. That will take me to the summary of that area, space, inside your report. Let's just close that down. And close this one down and this one. And we're going to go back to this HVAC plan. What we're going to do now is add in some ducting. Now, if we wanted to, we could come up to our Systems tab, go to our Duct tool, come down and choose a type of duct. For example, we could choose radius elbows and tabs. Choose a width and a height. These are all UK standard sizes. Choose an all-important offset. Generally that's going to be based on the level that your floor plan is looking at. Okay, but you can put in a specific offset if you know that you need to go higher or lower than that level based on the size of your void. Once we've done that, we can simply just start drawing. Exactly the same as drawing a line with inside of AutoCAD. You can see that as we start drawing, it automatically adds our fittings. In this case, it's added a radius elbow on there. Okay. So to add manually our ducting is relatively straightforward. However, we also have the ability to go in and get Revit to automatically create routes and duct systems for us. And that's what we're going to do instead, because generally it becomes a little bit easier for the designer because you're doing several things at once. For example, we can come up and see that we've got this VAV system. Okay. We can see that this is already part of a duct system, but I want to create another one to connect it to these. So I'm going to select one of these terminals and I'm going to say that I would like to create a system. It will ask me to give it a name and what that system type is going to be. I'm just going to press OK. See, this gives us a little dashed line around that terminal to say that that is now part of a duct system. We could say that we would like to select equipment. Okay. You notice that that won't let you select terminals, but that will allow you to come across and select your VAV unit. Let's pick this unit up, and you can now see that that gives us our dotted line around both the terminal and the VAV unit. What we're going to do now is actually say that we want to edit the system. It will automatically select the Add to System button, and we're just going to pick this terminal, and this one. We're leaving this one over here out purposely because we're going to come back to that and show you how you would edit afterwards. With those selected, we simply come across and choose Finish. If I hover over one of these tabs, one of these terminals now, and press the Tab key on my keyboard, standard functionality with inside of Revit, it will now highlight and show you that you can select that duct system as a whole. With that duct system selected, we can actually go ahead and say that we would like to generate a layout. Revit will try its best to determine a layout for you, but as you can see, it doesn't always give you a possible result. Okay. It does give you a number of options which you can flick through using this solution adjust over here. Or more importantly, we can actually pick up an edit layout tool and manually come in to make changes to any part of that layout just by selecting the sections of duct and dragging them around as necessary. You'll notice that when I'm selecting these, I'm also getting dimensions. If you want to be more accurate, you can obviously type the dimensions in. I'm quite happy with that layout at the moment, so I'm going to come up here and go ahead and press Finish Layout. Now, important thing to note is that what that will do is, yes, it will build your ducting for you, but what it's actually doing is it's just putting ducting in based on the connector sizes of your terminals and VAV unit. At the moment, it's not looking at sizing that ducting specific to the flow that's inside of those terminals or the units. I'm just going to come across and select, by again using my Tab key, that duct system. I want to point out that once you've got a duct system in, we can edit in any way, shape or form. For example, we can choose split elements to split sections of duct down manually should we want to. All of the other Revit modification tools such as align, offset, etc., will all still work within that environment. So we've split this piece of duct down, and what I'm going to do now is come across, go back to my Annotate tab and just add some tags. I'm just going to say that I would like to tag some of these ducts like so. We can also come in, as we saw earlier, and tag any of the other equipment. What I want to do now is make sure that I'm using the correct size ducts for the amount of flow. So what I can do is select our duct system, and I can actually come up to the ribbon and choose duct/pipe sizing. This tool is exactly the same regardless of whether you're using ducts or pipes, as you would probably guess by the name of the tool, but it's just a very simple calculation using friction or velocity or equal friction or static regain. You can give that a value, and you could say that it's using only friction of the material inside the duct, or friction and velocity, or friction or velocity, taking whichever one is worse. For this example, we're just going to use only friction, and we're not going to have any constraints. It's worth pointing out that we can add constraints if you know that you are restricted with height or width within the void. You can restrict by using simple value typings. We're just going to leave the values as they are there, and if you keep your eye on the ducting over here, if we press OK, Revit will go through and it will size the ducting based on that calculation. Let's go ahead and add this terminal in. Once again, we can come across and select the necessary VAV unit, duct system, sorry. And once we're in that duct system, we can say that we want to come across, go to the duct system itself. Okay. Once we're in that duct system, we can edit it just like we did earlier, choose Add to System, and then select the additional components. When we choose Finish Editing System this time, it will not automatically connect that terminal up with ducting. Why? So the reason's quite straightforward. If we look at the way the system's put together, there isn't actually a way that it can tap into this ducting at the moment. If we was to change this elbow to a T just by pressing this plus, if we'd have done that beforehand, it would have known that it could route that in. Okay? But it's clever enough to understand that there was an elbow there, it can't just come in and connect without you saying so. So now that we've got that T, we can reselect that system, generate a layout once more. It won't change what you've already generated over here. It will only look at what's changed. Again, it will give you some solutions based on whether you're looking at network, perimeter, or intersections. And somehow in this case it's giving me 3 suggestions. I'm obviously going to leave it on this one, the straight option. And again, you've got the ability to edit it if you wanted to. We're going to leave it exactly as it is and just press Finish Layout. One thing that's important to note here is it will not automatically size that new section of duct or the duct before it. Again, it's only going to automatically size the ducting when you tell it to. And the reason is quite straightforward once more. If you've got a lot of ducting and a lot of terminals and generally a big system within your file, that size calculation could take a few minutes. If you want to make a lot of changes, you're not going to want it to update that size every time you hit finish. So all you would need to do is once again come across and select the system as a whole and just rerun manually that sizing calculation. So there we've pretty easily added in our ducting. We can see that it's using fully detailed components, but should you want to drop that back and look at a more traditional 2D schematic view, for example, we can change to a coarse view to be able to see standard 2D-esque line drawings. I'm going to change it back to fine detail because I think I prefer it. So that's just a quick overview of the HVAC system. Let's just go and have a look at the plumbing. It works in a very similar way. I'm just going to go up to my plumbing, floor 2, public health. I've got a toilet just here. Okay. We've got 3 urinals, a couple of toilets with potentially a shower in this room with a drain, and a couple of sinks, a few sinks, sorry. What we want to do is connect all of these up with some piping. The process is quite similar. First things first, I'm just going to connect up all of these elements. Okay. So I'm going to come across, I'm going to select this urinal on the far left hand side, and just like with our ducting, we have the ability to create a system. If I choose to create a piping system, again we can name it, it gives it a system type, it picks up that it needs a sanitary system. We can then come in and say edit the system. It will automatically once again say add to system and allow us to select the rest of the components that we would like to use inside this system. If I press finish editing system, once again just like with our ducting we can use our tab selection procedure to see that system as a whole. Once I have that system in place, I can generate a layout which will give me some solutions. Okay. Now at the moment those solutions aren't going anywhere, it's just connecting all of those components together. I would like to place a base, so to establish a source for an outlet for example, and I'm going to place that in a small void that I have just over here. That will change the layout, okay, specific to where you've placed the base. I'm going to change the diameter of that outlet to 100, okay, and we could give it an offset, let's just say minus 900, because we want to add a 1% slope, let's say, on all of those. I'm just going to turn on my solution viewer, and that should then give you a better solution. I still want to edit the layout because I want to grab these pipes and just move them inside of this void just here, and we can move them singly or all at the same time. Once I've done that, I'm just going to choose to finish the layout, and that will generate pipes from my components. Once again, that works the same way as the ducting. You can select it and you have that as a single run. Now what we have here is 3 urinals, and you could say that you're going to have to be pretty friendly to use these 2 at the same time. These urinals have clearly just been placed in a drawing without too much regard to their position. So what I'm going to do is just use some standard Revit functionality to say that I would like to add a dimension between the center line of each of these urinals, and I want that to be equal, meaning that we've got equal spacing between each component. I then want to take a dimension from the wall to this urinal and the same on the other side. I want to select this urinal and change the dimension in question to 400. The same on the other side, and you'll notice that my equal dimension that we've added a few seconds ago is automatically updating. But more importantly, as well as that, our piping system is moving and generating itself again automatically based on those system changes. Let's just come across and have a look at these sinks. We're just going to connect the hot and cold taps up with these sinks. Relatively easy to do. If you select a sink, you'll notice that you get a cold tap icon, a hot tap icon, and something that looks a little bit like a U-bend to show you that that's going to be a drain. I can right click directly over these and say that I would like to draw a pipe. This puts a pipe on the end of your mouse. You could come up and choose a standard if you want to, but it's automatically going to pick a diameter and a standard based on the type of connector that you've chosen at the other end. I'm going to come in and choose an offset, so let's just say 750, and for this example I'm not just going to run the pipes along the wall. That would be reality, but I don't want to tell the plumber where to put his pipes, so I'm just going to bring that down and do more of a schematical view for this instance. So with that offset on, I'm going to come down here and click my mouse, draw over here. You'll notice it's snapping very nicely for me, so I can reconnect that at the other end. Obviously this is going to go somewhere else, and we'll look at that in just a second. Let's select the middle sink, right click over the cold, and say that we want to, we don't even have to go that far. Select the sink, come up to connect into, under layout. It will show you your three connectors, being your cold, your hot, and your drainage. Select the cold, press OK, and choose your existing pipe, and it will connect the two together. Let's do the same process for the hot. So we're going to right click and draw the pipe, remembering to give it a different offset. Obviously we don't want it to clash with this pipe over here. Let's draw that in. I'm going to purposely draw through these two pipes. You'll see that Revit will automatically region and trim those out for me. Okay. We're then just going to select the middle sink, connect into. You'll notice that the cold has gone because it's got a connection. Choose the hot and then select your existing pipe. Let's now go ahead and choose to add some T's in where the elbows currently are, and then once again you can come over them, draw a pipe, and continue until this is connected up to the rest of the system. We're not going to add the drainage in this example because I think you can get the idea from what I've done so far that the process is going to be exactly the same, but you'll be drawing a drainage pipe rather than a hot or cold water pipe. Let's just have a look at what we've done there. Because we're drawing in 2D, we've actually got 3D being generated for us automatically. So the 3D itself is being generated automatically. Let's come across to plumbing and just take a look at 3D views for public health. I've obviously pre-configured this view to show the walls and the building transparent, but we can see that that's gone in and drawn all of our pipes automatically for us in 3D, even though we're only using 2D to draw them. Let me just go ahead and select this crop box that I've got on here and just drag that out, and you can see that we've got our pipes in over here. And once again, just like with our HVAC, we can come in and say, well, actually we want to look at a schematic, so we change that to a cores view, and that will show us a schematical drawing rather than a detailed drawing. Let's just change that back to fine and have a look at this section. I have a section view set up. Okay. I can give that section view a specific depth and choose to activate it. I can edit directly inside of this section view if I should want to, in exactly the same way, just by picking up a component and changing it. So for example, if I move this toilet, you'll notice that the pipe has automatically updated both in 2D and in 3D. So the last thing I want to take a look at here is lighting. And again, the procedure is very much the same. It's following the same intuitive tools that we're already seeing. I've got a lighting floor plan where we can see that we've got our lights placed into our rooms. And perhaps what I want to do to begin with is have a look at some lux levels. So I can come across to this view and I can say that I would like to view a color map onto this view, or a color scheme, and I want to look at perhaps required lighting or maybe average illumination. You can see from this table on the right hand side how this has been set up, and it's going to colour certain areas specific to their lux values. If I press OK, the view will update to show that option. We have got the ability to add a colour fill legend should we want to, like so. Now the great thing about this is it's live updating. So for instance, this room here that's green currently has no lights. If I pick up this component and choose to copy it inside of that area, you'll notice that the colours automatically start to update. And again, this is the great thing about Revit and BIM in general. You have a single 3D model. You edit it in one area and everything else updates. This gives you the ability to perhaps go in and determine what kind of lighting a room requires. Now these specific lights have been downloaded from Autodesk Seek and are manufactured lights, so they are real life lights. They're using photometric properties. Okay? Anyone that doesn't know what photometric properties are, it essentially means that this light has real life properties on its source, Kelvin colours, okay? Anything from a property perspective that you would find in a real life light is put into these lights if they are photometric. What this means is we have the ability to potentially, we'll use the word simulate, to see what effect these lights will have on a room. Now I don't have a setup in this current file, but what I'm going to do, just to give you an idea, is just open a little bit of Blue Peter style. Here's one I made earlier. We're going to come down into a folder that I've already got and just have a look at this file. And this is just to show you that if you add photometric lights into your scene in Revit, Revit has a mental ray renderer built in. You can get pretty good results on quality, but more importantly, you've got real life photometric properties giving you a photorealistic output. So you can render inside of Revit to a variety of different qualities to give you an idea of what lights affect that space. Now all of these renders were done specifically on my PC, and this specific render took an hour or so to run through with best quality on the lights and the shadows. The materials aren't fantastic, but again we're only looking at materials and shadows in this instance. You have got the ability to do cloud renders, which obviously are quicker because they go up to the cloud. They don't take up your CPU, okay? And you've got the ability to go through and run a number of options on those cloud renders, and again they're based on those photometric lights. Also, don't forget, as part of the building design suite, you get 3ds Max Design. 3ds Max Design has powerful light analysis tools built in, and we have the ability to do a one-click workflow to send our Revit model with its lights directly into 3ds Max for exterior or interior rendering. We can do that and get some very, very accurate and high-end light analysis based on those real-life lights. Let's just go back to our MEP file. And we're just going to go back to our standard lighting floor plan. In that floor plan, we can see that we've got everything wired up apart from in this area just here. And again, the procedure follows the same intuitive procedure that we've looked at so far. We can select a light and choose that we would like to create a power system. We need to select a panel, which is going to be this one over here. And then we can say that we would like to edit the circuit and add the additional light and this switch. Once we've done that, we can say finish editing the circuit, select the circuit in question, and say that we would like perhaps arced or chamfered wires, whichever you would prefer. I'm going to choose arced wire. In Revit 2015 you will get a wire that goes straight back to the terminal. I don't want that, so I'm just going to go in and just manually move this wire back just so it's pointing roughly in the right area. It's completely dependent on what you want to show. And as you can see, that's wired that all up for me. So we're starting to get something that's near enough done. We've only got a couple of minutes left. So what we're going to do is just have a quick look at perhaps how we might do a walkthrough with inside of Revit. Now this is more from an architectural perspective, I would guess, but it's worthwhile pointing out that we can do this. You might want to do a walkthrough AVI, which is rendered to show the lighting within your building, or it might be that you've got some plant and you need to walk through your plant room to determine if there's anything untoward going on. Rendering and walkthroughs inside of Revit is relatively straightforward. We can come up to View, say that we would like to create a 3D walkthrough, and then it's just a case of literally coming in and clicking as if you're drawing a line or a spline where you would like your path to go inside of Revit. And this can be as long or as short as you want. Once you've done, you get something that looks like this. With that walkthrough, we have the ability to come down and look at walkthroughs. It might be hidden based on my browser configuration, so let's just go ahead and change my organization to show everything and come down to walkthroughs. If I activate that walkthrough, let's just put it onto a realistic view just so we can see some materials, and let's just select the walkthrough in question and say that we would like to go back to the start, and once we're back to the start we can play. It's that quick to be able to get a walkthrough inside of Revit. Should have opened the door, but again you get the general idea. Let's just wait for that to finish, nearly there, and just close down the walkthrough window. And finally, let's just go and have a look at how we might look at some clashing. So we're going back to what we've done from a HVAC perspective. Let's just change my browser organization to back to what it was before. Go back to mechanical, HVAC, floor plans, and my level 1. So we've added all these pipes in, and I want to see if there's any clashes. Those clashes could be with each other, with other pipes, other terminals or components, or with architectural aspects of the building. Let's just come across and have a look at my interference area. I should have somewhere. There we go. So I've got an interference view. Again, I've just pre-configured it, and we can see that I've got a number of HVAC systems in here. We're just going to come across to collaborate. Again, remember, this is not my architectural file. It's one that we've imported in and linked. However, I can still say run an interference check based on the office building that we have imported. I want to look at the walls in this instance, and then we're going to look at the current project and have a look at our ducts and our fittings. We can select as many of these as possible, or as many as we need to. We're going to leave it on that and press OK. Revit will go away and it will run an interference check. Once that's completed, it will give me a report. So out of all of the ducts and the walls, it's found several clashes. Let's just come down to the bottom one here. We can highlight it. It highlights it in the model. If we can't see it in the model, we can press show and it will get to that area for us. If we expand that, we can see the specific duct or wall causing the problem, and again we can select that item and hit show to zoom in. This makes it very quick to do interference checking and check for clashes within our system. And just bear in mind that because we're working inside of Revit, if we wanted to, we could take this wall, very quickly edit the profile and add a cut for that pipe. Because we've done that inside of that drawing, it would update the architectural's model and they would get the notification and update changes of that. Finally, once you're done, it's a case of putting everything down onto a sheet. And again, if you're AutoCAD users, you'll be used to using paper space. We have a similar scenario inside of Revit. I can go to my sheets, say that I would like to create a new sheet, specific size title block, press OK, and that places that down onto your paper. I can then simply come up and find the views that I would like. So I want my HVAC mechanical view, drag and drop and place that in. Select the view. It works just like a viewport in AutoCAD. We can change the scale. 1 to 200, probably a little bit small. Let's go 1 to 100. And then just move that into position. Just move that line so it's in line. There we go. That works exactly the same whether it's a floor plan, a schedule. Once you place a schedule, we can obviously split that table down and edit what's shown. I'm just going to say to split it, obviously it's going to go over my paper space, but I'm not too worried for this example. We can also throw in 3D views very quickly with exactly the same process. So that's a quick whistle-stop tour of Revit MEP. We've gone through some simple examples to show you how you would use the HVAC tools inside of Revit to create ducting systems, how we would go in and create piping systems, and how we would create lighting systems. We've thrown that together with some calculations based on the type of building from a HVAC perspective. We've looked at heating and cooling loads and how we can automatically size our ducts and our pipes to suit. We then looked at schedules and how they link back to our 3D and 2D models, and generally how that we've got those powerful collaboration tools inside of Revit to link to an architect's file and add in information. So it was a quick whistle-stop tour. I hope it's been useful, and until next time, see you soon. Thank you.